Um,
All together. Very lost.
so what I'm looking at, or what we're looking at right now, is on the OneNote. So I have the test 2 format, 10 multiple choice questions, and a free response style question on part 1. Part 2 is like 8 problems. A lot of them will be like take the derivative of function style problems. And then again, 1 free response question. That's the test format. The first part is the no calculator piece. The second part is the calculator piece. So skills that'll be emphasized, being able to calculate the average rate of change for a function. When we say average rate of change, we mean slope. Can you find the slope given a graph, given an equation, given a table, given a piecewise function? So just depending how it's presented, you should be able to calculate the instantaneous rate of change. When we say instantaneous rate of change, we mean like derivative, right? Slope of the tangent line, all that. Yes, Marcelo?
When you said piecewise function slope, does that mean you have to find the slope for each piece of the function?
Or it might be something where like, like one part has constant slope and another part doesn't, kind of thing. So like you might have to choose the appropriate part of the function to make your estimate with. You know what I mean? So again, calculating instantaneous rate of change, like slope. Again, whether it's from a graph or an equation or a table or piecewise, regardless of how I present the function to you, you should be able to do that. You should be familiar with the limit definition of a derivative. However, I am able to evaluate the limit, or evaluate this kind of a limit just by taking a derivative. So like, I'm not going to ask you to use the definition of a derivative to find the limit or find the derivative of anything. You don't have to do it that way. What you want to be able to do is recognize, be like, oh, this limit is in the form of a definition of a derivative. All I need to do is take the derivative of this f of x here, the f of x piece, and that's the answer to this limit. That's what you want to be able to do, is recognize the form of the limit as, oh, all we're talking about is the derivative of this. Let me just take the derivative of it using my shortcut and not have to grind it. And we can look at an example of what I mean by that if you want. If you need to circle back to that. Like you should be familiar with the different vocabulary or notation attached to that instantaneous rate of change or derivative or slope of tangent line or f prime or y prime or dy dx or ddx of f of x or so when you see those symbols, you're like, okay, I know what this means. I know what we're asked to do. You should be able to tell where a function is not differentiable and justified. So whether it's you're looking at a graph, you'll pick out where the function is differentiable or not from a picture or from an equation or from a piecewise function. And you should be able to apply derivative shortcuts to find definite derivatives. That's where it's like, what we're talking about there is like the slope of the tangent line at x equals 2 or something, where it's at a specific value. So we're not talking about the equation for a derivative, we're actually just talking about the value. Everybody okay with that idea? And you should be able to do that whether it's talking about your functions are graphs or tabular or from equations or piecewise. And then should know and be able to use the derivative relationship between position, velocity, and acceleration. Right? What's the relationship? Just derivatives all the way down, right? The derivative of position is velocity, the derivative of velocity is acceleration. So it's just derivatives all the way down.
So to find acceleration, you do the second derivative.
So acceleration is the second derivative of position, or the first derivative of velocity. The third derivative of position is named after me. Anybody know what the physics students? Sure. Ha ha. Nobody's in the mood for it. I'm trying, guys. I get it though. So that's kind of the list of skills. Again, the primary skill here is the definition of a derivative and this idea of differentiability, right? Those are like the primary concept going on. The rest of this is really just kind of mechanics. Like, can you find these derivatives now? Just like from the last test, I have a big block of sample multiple choice questions that I've dropped into the OneNote. The answer key for all of these are there as well, so as you're doing them, you can check things. It seems like you guys would prefer to have them in paper than going through the MyAP and doing it just from a feedback standpoint, you can do it right away. I also have some sample free response style questions. And there's a handful of those. To get a feel for what that might look like. We've now done enough content to where I can find some free response questions that only cover what we've done so far in class that I thought were appropriate. So I have those in there, and I have the website provided solutions to these. I pull these from the MyAP or whatever, and they give their scoring, okay, this was how many points, and these are where the points are for, and this is what you might have to show. So sometimes it's you gotta do a little bit of reading to get the idea of what the answer is that they're looking for. But all of that's on there. Is everybody okay with that? Okay. We've already done the 3-2 work. We did that last time. So there's nothing new that needs to be covered today. Honestly, I'd rather, given what's kind of been going on, just give you to stop here and let you work on what you feel up to working on. We can deal with questions. We have a review day next class. So everything is just on a hard pause right now. Anyway, so it's not a big deal. If you have questions come up today, or if you just need to have a little bit of community, you're free to, to ask questions about stuff, or if you just need to talk to your friends about what's going on, that's okay. So I'm gonna stop and back out as we've talked about some stuff. That's all I need to do today. If you have any questions for me, or if you need my help math-wise or other, feel free to reach out. I can sit and listen, give you thoughts. event, like, you can do that. You need to catch up on something, you can do that. You just wanna like process, you can do that. Fair enough? Okay. I'm gonna step out, back out now, and leave it up to you guys on what you need to do, okay? Hi, man.